Okay, good evening, class. Yes. So as I say, I will discuss a few questions in exercise 6.1 and also two past year questions. All right, for the iterative method. Still remember iterative method, okay, where you need to express the equation that you are going to find the approximate roots into the form x equals gx, right? And the condition is your when you sub your initial x naught into the f g prime x, the modulus must be less than 1. That means that it will give a sequence of approximation which is converged to the actual answer. All right. So today we will see, and also last lesson we have discussed a few examples in the textbook, right? So today we are going to see how we are going to answer the question in the correct method. All right. Alright, so first I'm going to discuss exercise 6.1, question 1b. So you see question 1 say, for each of the following, you are asking to show how the iterative formula is derived from the given equation and determine whether the iterative formula converge to a root. And number 3, state the root of the equation correct to 3 decimal places if the formula is converged. Alright, so I'm going to discuss question 1b. So this is the equation that we are going to ask. We are going to find the approximate root of x plus e to the power of negative x minus 2 equals 0. Alright, so they want us to show how we get this iterative formula. Alright, and use this, the initial value of x that we are going to use is 1.84. Alright, so you will see. Remember, so first step, this is very easy. Can see that we just left the x at the left hand side, then these two terms we shift to the right hand side, then become like this. All right, so it's very simple to get this iterative formula. All right, so we calculate g prime x, see whether it's converged or not, right? So we have to calculate g prime x. So the right hand side is the gx, so differentiate gx, differentiate to 0. Alright, differentiate e negative x, you get e negative x. Remember, multiply differentiate negative x. So negative x, differentiate negative x is negative 1. So negative 1 move in front, so become positive. Alright, then we sub the first initial value of x that we are going to use, 1.84, into our g prime x. We want to calculate the modulus. Means e to the power of negative 1.84. Alright, so when you use your calculator, you get 0.1588, which is less than 1. Alright, so if it is less than 1 means this iterative formula will give us a series of approximation which is converged to the actual root. So means can be used. Alright, now we start how we are going to calculate. Okay. So x naught is 1.84. So x1 will be sub 1.84 into the gx. This one gx. Remember I say show you sub the x naught into the gx. Don't skip. Alright, so when you use your calculator, you get 1.84118. Alright, so remember the question 1, the answer in 3 decimal places. We always express 2 more than what the question 1 means, 5 decimal places. Okay, so remember we say that actually you can use your calculator, or you can press your calculator, key in this formula, 2 minus e to the power of negative x. Alright, okay, hold on. So key in this one, still remember how to key in, right? So 2, you can see 2 minus e is, hold on, let me see where is the e. Okay, here, shift this one. Alright, so negative, use the red color alpha, remember? Yeah, can you see that? I already key in the formula inside. 2 minus e to the power of negative x. Then next, can see, then you're going to calculate, press the button, calculate, CALC. Then they ask what the value of x you want. So the first approximation is 1 point, press 1.84. See? So for my calculator, I have to press twice lah. Yeah. So you see they give me the answer 1.84118. Or 5 decimal 1.84118. So 1.84118. Alright. Then next step, same. Next step, remember I say show at least 2 times. You sub the previous x into the gx, or at least 2 times. Alright. So you just write. Then you can use your formula in your calculator and press right. So again, press the buttons, calculate. Alright, and press this one, the 5 decimal places that we written here, 1.84118. So 1.84118. See? Then press 2 times. For me, my calculator have to press 2 times. So you see the answer? 1.84137. Because it's 1369, right? So when you convert to 5 decimal, it's 1.84137. So 1.84137. Alright, 5 decimal places. Okay, so next. So you see, as I said just now, you must show at least twice. You sub the previous x into the formula. Then next, you can just write the answer. Just use your calculator, like what I showed just now. Okay, press again the calculate. Just now the second answer is this one, 1.84137. So press 1.84137. Press the 5 decimal one. Okay, then press 2 times. Then you see the next answer is 1.84140. 1.84140. Then repeat the same step. So you see that my x, the fourth one already get 2 continuous answer which are the same. Alright, then we can stop. Therefore, the root is convert to 3 decimal places is 1.841. Then remember, yes, very important. In bracket, write your answer into how many decimal places or significant figures. Is it okay? So this is the actual correct step. Alright, so next I'm going to discuss C. So this is the formula for C. This is the equation for C, and we have to show how we get this iterative formula. Okay, after that we have to show whether this iterative formula is converged or not by using x naught equals 0.5. Alright, so this one not difficult. Alright, so you see that this is the equation. So the iterative that we want to show is only 1x left here, and there remain 2x cubed plus 1. So I know that 2x cubed plus 1 I remain here, so x squared I shift here. Alright, and you know that x squared is x times x I just rearrange lah. So 1x shift here. This is how we get this iterative formula. Alright, then next step, let the right hand side as your gx. Then differentiate it. Alright, so differentiate 2x squared is 4x. Differentiate 1 over x is negative 1 over x squared. Alright, so just now the first initial value of x that we are going to use is 0.5. Okay, so I sub 0.5 into my g prime x. Alright, sub in. So I get this answer. So the modulus of negative 2 is 2, which is bigger than 1. Alright, so this iterative formula give me the g prime x, where the modulus of g prime x is bigger than 1. So means that this iterative formula cannot give you the correct answer, which is converged to the actual root. It will be diverged. Okay, so this is question 1. So 1A you do as homework lah. You try 1A at home. Okay, then I'm going to discuss question 2. Alright, I'm going to discuss question 2. So the rest will be similarly. So your homework will be 1A, 3, 4, 5. Okay. So question 2 say that find the equation which is solved by the iterative formula. This one is reverse. Before this, they give you equation and ask you to show the iterative. Now they give you the iterative and they want you to find back the original equation. Excuse me. Then starting with x naught, use this initial value of x. Use the iterative formula, means this one to find x1, x2, x3 and x4. correct to 3 decimal places. Okay, so they will ask you to find the root, but they want you to calculate until x4. Then you just follow the instruction. All right. Okay, so this is the solution. Okay. Hold on. Okay, so this is solution. So they give us this iterative formula. All right, so first I shift x 2 to left hand side, so x minus 2. All right, then I shift x squared here. All right, so expand it, so x cubed minus 2x squared, 1 shift to the left, minus 1. So this is the original equation. Alright, so this question they just ask us to use, means definitely it is converge lah, also we just use lah, no need to show. Alright, so x0 is 2.5, then x1 will be sub 2.5 into our gx, remember is gx, show the formula and you sub in the value of x. Alright, so use your calculator like what I teach you just now, so you get 2.160, because the question 1 3 decimal places, so for this we just follow. Alright, then x2 is we sub 2.160 into the gx again. Remember, show at least 2 times, then when you press the calculator you get this. Alright, we still write 5 decimal places and we convert to 3. See, because next step we are going to use this one into our calculation. Alright, so the third x will be this one. Okay, then this is the 5 decimal places answer, then we convert to 3 decimal places. Alright, and x power 4, same lah. We use this 5 decimal places answer. Alright, we use this 5 decimal places answer into the formula, and we get 5 decimal places answer and convert to 3. Alright, so this one, even though you see that we don't get 2 consecutive answers which are the same, but doesn't matter because the question never asks us to find the formula. Okay, they just want us to calculate until x4. Alright, okay, so it's basically this is the step, alright, that you need to show. Alright, so your homework will be 1A, 2, 3, 4, 5 lah. Okay, alright, now we are going to see the past year question, SCPM 2005. Alright, okay, where's my where's my question? Okay, alright, here. Okay. Alright, this is a question for STPM 2015. First, they want you to show that this equation has at least a real root in the interval 2, 3. Remember this one we have discussed. How to show this equation has at least a real root in the interval. So you know that we have to find F2, F3 and show that it has opposite sign. Alright, so you see 2 marks only. Then determine which of the iterations. They give you 2 iterative formula. Then they ask you to show which one is more likely to give a convergent sequence of approximation to a root in the interval 2, 3. They give you 2. So we have to prove which one we can use. Then use your choice with x0 equals 2.5 to determine a root corrects to 3 decimal places. Alright, so only this part, they give you 9 marks. So you know that we have to calculate calculate more detailed steps. Alright, okay, let's look at the answer. Okay, make it smaller so that you can see the whole thing. Okay, so this is the equation given. Alright, so remember we have to move all the terms to the left hand side and right hand side make it 0 only. Then we let the left hand side as fx. Alright, then we sub 2 into the f and I get -1. Then I sub 3 into the f and I get 25. Alright, so remember just now the question say is in the interval 2, 3. Alright, Then the conclusion is, since F2 multiplied F3 is a negative, of course, negative 1 times 25 is negative. You can write this sentence, or you can write, remember the one, since F2 and F3 have different sign. Okay, remember? You can use that one also. Therefore, there is at least a root in the interval 2, 3. So 2 marks only. Alright, so 1 mark will be given for you to to calculate your F2 and F3. Then 1 mark will be the conclusion. Only 2 marks. Alright, so 1 mark for the calculation and 1 mark for the conclusion. So 2 marks. Okay, the next part will be 9 marks. So we are going to determine which iterative formulas can be used. Alright, so, alright, here. So the first one is this. The first iterative formula is this one. It's very simple. They actually just shift the x to this side. So left these 3 terms here. So this will be our gx. X equals gx. So this will be our gx. Alright? So the step will be, so let gx equals x power 4 minus 2x cubed plus 1. Then we differentiate it. So get 4x cubed minus 6x squared. Alright, since just now the question tells us that we are going to use this initial value 2.5. So we use 2.5 lah. We sub 2.5 into the g prime x. Like this, sub x equals 2.5 into the g prime x. We want to calculate the modulus value. Which is given us 25. And you see 25 is definitely more than 1. Alright, so means that this iterative formula will give us a diverge approximations of value of x. Means they cannot give us the answer. Alright, so this one cannot be used. Okay, so the next one, of course lah, since they ask us to show, we have to prove both lah, cannot prove one only. Okay, so the second iterative formula is this one. Alright, this one. Okay, so the right hand side is this thing, the right hand side. So we let gx equals to the right hand side. Alright, so if I differentiate this one, I have to use quotient rules, which is more complicated lah. So I do long division because I see that it is an improper fraction. I do long division and I express in this way. Easier lah. Alright, I express in this way. So I move this thing up. Then I differentiate, which is easier. Okay, differentiate 2, you get 0. Okay, differentiate this term, index in front, index minus 1, multiply f prime x inside. So this is my g prime x. Alright, then we calculate the modulus of g prime x. So again, I use 2.5. Alright, so when you sub in 2.5 into your g prime x, so this is the value that I get. So the modulus is this one. So very clear, this value is less than 1. Okay, therefore, this iterative formula is converged. Means that will be more likely to give a convergent sequence of approximation to a root. Alright? Okay, so means that we are going to use this one. Now we start our calculation as what we have discussed just now. Alright, very simple. We use x naught equals 2.5 because this is given. So we just follow. X1 will be, you sub g naught into your g. You sub x naught into your g. I mean sub 2.5 into your g. So remember, we have to show at least twice. Alright, sub 2.5 into your gx. You can use this one. You can use this one, up to you. But I use back the original. Alright, show it. Then press the calculator. Because the question wants 3 decimal places, right? So again, we express our answer in 5 decimal places. Then, second time, sub this answer with 5 decimal places into the gx again. Alright, then press the calculator like what I show you. How you can key in this formula in your calculator, and then every time you just press the calculate button. Alright, then I get this answer in 5 decimal places. Okay, show at least twice. Then others, you can just press answer only. So you see that the answer is like this: 1159, 1180, 1176. So you will see that it is like increase, a decrease, but increase, then decrease again. Okay, then like slightly increase, doesn't matter. We just, because after that you just press calculator only until you see I get my x7 and x8 exactly two subsequent answer which are the same. So we can stop lah. Therefore, convert to 3 decimal places. Our root will be 2.118. Alright, so all these steps give you 9 marks. So all the steps is not difficult, you see, not difficult, but all the steps you must show clearly. Don't skip any steps. Alright. So this is STPM 2015. Okay, so the next one will be STPM 2019. You can refer to the past question that I photo set to you. Alright, so this is STPM 2019 question 6. It has a little bit of integration doesn't matter, I will show you. Alright, so the question the question like this: if integrate 1 over x plus half dx from 1 to beta is equals to 4. This is given. Show that the positive constant beta satisfied this equation. Means we have to integrate this one equals 4. We solve this thing and get until like this. So again, 2 marks only. Alright. Then next, use the equation in A as an iterative formula. Means this one. Alright, this one. With initial value of 5.5 to approximate the value of beta, correct to 2 decimal places. 4 marks, so it won't be too long. Alright, so this is a question. Alright, now look at the answer. Okay. Alright, so first we see the integration. Integration. Before we go to this, I explain a bit differentiation. Remember we said when differentiate ln x with respect to x, we get 1 over x. Differentiate ln x, you get 1 over x. And in Form 5 also you have learned, actually integration is the reverse of differentiation. So if differentiate ln x, you get 1 over x, then integrate 1 over x, you get back your ln x. Alright, this is the concept that we're going to use. Alright, only this part lah. Okay, so now we integrate. So integrate 1 over x, we get ln x. Integrate half, we get half x. I hope you still remember a little bit about integration. Okay, then the boundary will be 1 and beta, and this thing equals to 4. This is the definite integration. Alright, so next step is we sub the boundary into the integrals. Alright, so sub upper first. So sub beta into here. So ln beta plus half beta. Then minus sub 1 in. So sub 1 ln 1 minus so become negative half and 1. And this thing equals to 4. So we just arrange this. Okay, so I left my half beta here. Okay, so this is minus half. So shift here plus half. 4 plus half is 9 over 2. Ln 1 is 0. Okay, then ln beta, I shift here become minus ln beta. See? Then next step, the whole equation times 2. So you have beta equals 9 minus 2 ln beta. This is how we get this equation. Okay, so 2 marks only. So 1 mark for your integration, 1 mark for you to sub in the boundaries and get what the equation show you. See, 2 marks only. Alright, okay, now we want to use this. The question say use the iterative formula in A. Alright, so normally we use x, right? Normally we use x. X equals gx. Iterative formula, x equals gx. Now same, just that the change x become beta only. So x become beta. So this is your g beta lor. Okay, right? So next step. Alright, so the right hand side will be our g beta lor. So g beta is 9 minus 2 ln beta. Okay, so this one we don't have to prove whether it's converged or not, because the question just asks us to find the roots. Okay, so we don't have to prove whether this one can get is converged or not. Definitely is converged. All right, because only given you 4 marks. All right, so the initial beta the initial value of beta that we're going to use is 5.5. Oh, it's actually same like what we have done, but before this we are using x, now we use beta only. All right, so first step, sub your first initial value into your G. Means sub in here lah, 9 minus 2 ln 5.5. So use your calculator because the question want 2 decimal places. So we express our answer in 4 decimal places. Okay. Then again, repeat the same step. Repeat the same step. All right, remember? At least twice. Sub the previous answer 5.5905 into the GX again, G beta again. All right, press the calculator. I get 5.5579. All right, then following, you just use your calculator. Key in. Remember to key in this formula into your calculator. Then every time you just press calculate. All right, and you see I get a sequence of answers. All very close already, but it's like swinging. This one increase, decrease, increase, decrease a little bit, then increase back a little bit. All right, so you see that I calculate until beta 7. Yet I cannot get 2 consecutive same. So in this case, actually we can stop. All right, we can stop. Let's say we convert to 3 decimal places lah. If convert to 3 decimal places, this is still 567, but this is 566. This is also 566. All right, can stop already. Actually, can stop already for this question lah. Okay, so can stop already. So 5.566, I get 2 consecutive same with 3 decimal places. Because it's too many already lah. So for this question is something special. We can stop. Therefore, convert to 2 decimal places. The beta is 5.57. 5.57. All right. So this is how you can get your 4 marks. It's just that simple. Okay. All right. So your homework will be, as I say, exercise 6.1, which is in page 178. So all others question that I haven't discussed, just like I say 1A and 3, 4, 5, right? Then please do STPM 2020 repeat paper. 2020 repeat paper, question 6, also iterative question. Okay, I show you. Yeah, here. 2020 repeat paper, question 6. So you see, show that this equation has a real root in the interval 3, 4. So this is what I mean. They like to ask you a question like this. All right. Then determine the iterative formula in this form, where P is a constant. Means rearrange this thing until you get this. All right. Of course, not in P anymore. P will be a value after you rearrange this. Okay. Another 2 marks. I think you need to be very careful. Be very careful. Because they give you 2 marks just to rearrange this one. They give you 2 marks means maybe you have to see how to rearrange. Okay, then hence find the root of equation correct to 3 decimal places with the initial approximation 3. All right, they ask you to use this one. All right, so class, listen. So later, after you finish your homework, I want you to send me the solution for question 6. All right, snap your solution. Please convert to PDF form. All right. Remember, before this, I already asked you to create a Google Drive, your own Google Drive. Yes. So please upload your answer into your own Google Drive and you send the link to me. All right. Then I will check one by one. All right. So please complete this exercise within these few days lah. Okay, so next week we will go to Newton-Raphson method. Okay, all right. Thank you, class. Bye.